Happy Pi Day to all. In this video, let's look at a very nice connection between pi and Fibonacci numbers. How can we find the value of pi using Fibonacci numbers? You may thought they are very unrelated and there is no connection between them. But let me show you a very beautiful connection between them. So here is our infinite series for pi where f of n is a Fibonacci series. You may thought what the heck is this, but I will show you a very nice proof of this series. So we all know that Fibonacci numbers starts from 0, next term is 1, and we find next term by adding last two terms. So it goes like 0, 1, 1, 2, 3, 5, 8, and so on, 13, 21, and etc. So here is a very beautiful property, or you can say identity, of Fibonacci sequence which I am leaving as an exercise for reader. And you can see here a very famous identity of 10a plus b. You may thought what the heck is this? Why we are suddenly revising some trigonometry formula. So don't worry, you will see it later. And using this identity on tan inverse x and tan inverse y, we can see this result that tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus x times y. And if I replace x with 1 upon x and y with 1 upon y, I will get this equation. So here, now if I start putting values for x and y, for example, let put x is equals to 2 and y is equals to 3, I will get tan inverse 1. If now I put x is equals to 5 and y is equals to 8, I will get 1 upon 3. And 13 and 21, I will get tan inverse 1 upon 8. So you may notice something strange property about these numbers. So if I put all the values, so I can write tan inverse 1 is equals to tan inverse half plus tan inverse 1 upon 5 plus tan inverse 1 upon 13 plus tan inverse 1 upon 12. So you can clearly see that all these numbers from the starting except the last one are all odd Fibonacci numbers, and the last one is the next number to the last odd number. So I can write this as sum of all odd Fibonacci numbers plus the last next even Fibonacci number. And now if I increase my value of m sufficiently, so I can ignore that even term. I can write this as tan inverse 1 is equals to summation from n is equals to 1 to infinity tan inverse 1 upon f of 2n plus 1, and we know that tan inverse of 1 is pi by 4. So you will get the formula. And now we know that there is a famous infinite series expansion of tan inverse x. And now if I use this series expansion into our original formula, you will get pi is equals to summation n from 1 to infinity summation k from 0 to infinity 4 times minus 1 to the power k divided by 2k plus 1 times f of 2n plus 1 to the power 2k plus 1. So here is the method to calculate pi using Fibonacci numbers. Comment your thoughts on this and share this with your friends.